Okay, remember our oxidation number rules from last class. Also, I have decided that your exam for this unit will be a take-home exam. So that will be given on the day of the normal exam day. Okay. So using our oxidation numbers from last time, we will be able to see in a reaction or a half reaction if an element was oxidized or reduced. Remember, oxidation numbers go by single elements at a time, even if it's a compound. Okay, so if the number if it goes up from one side to the other, the element was oxidized. If oxidation number goes down, the element is reduced. And recall, this is from one side of the equation to another. As we are doing this, you need to think about oxidation numbers and how they're going to affect each element by itself, because remember, oxidation numbers are by element. So single elements are 0, if you recall. And so both single elements do not show a charge here, which means they are both 0. Also, oxygen is usually -2. Okay, there is really no exception to that rule, except hydroxide or peroxide, hydrogen peroxide, which this is not that situation. Okay, so as we do that, recall that you can pull out single polyatomics. So if we did that, here is our polyatomic. Okay, oxygen is usually -2. Recall that this has a 2- charge, so it's going to be X plus 4 times the -2. And recall that 4 is because there's a 4 subscript in sulfate, and that is going to be equal to the total -2 charge. So then, if we solve this algebraically, we get that X is equal to +6, because we shift the -8 to the other side, and you do that by adding it to the other side, because that's the opposite of subtracting. And so we get that S is +6. It will be +6 in both of these compounds, because each of them have the exact same sulfate, and sulfate always has a -2 overall charge. Okay, so now we're left with copper and zinc that are in these sulfate compounds. And if you notice, if sulfate is equal to -2, that means its overall oxidation number is -2. We can also get that by adding our +6 plus -8. We get -2. And in order for the entire thing to equal 0, which is the goal of all of this, both copper and zinc in these compounds must be +2. Okay, so as we go across, hopefully you can see that we've got some change happening on each side. So zinc from here to here is going up. And when it increases, we say that the reaction or that element was oxidized. As we go from copper, we can see that copper is going down from +2 to negative or to 0. And because that happened, we say that copper was reduced. So when the oxidation number decreases, it is reduction. When the oxidation number increases, it is oxidized. So we would say that zinc is oxidized and copper in copper sulfate is reduced. Okay, I'm going to do 2 of these reactions and you can try the third at home. Okay, so first thing we need to do again is find oxidation numbers. That is always your first step. So single elements are 0, period. There is no exception to that unless they show a charge. They do not show a charge. I understand some of you are thinking, hey, this is not a single element, but remember that halogens are diatomic, which means they come in 2s in nature. And so that would imply that they are stable at that problem. Also, the last rule, that was the one I wrote down, is that group 1 and 2 metals keep their charge. There is absolutely no exception to that group 1 and 2 metals keep their charge. So potassium is in group 1 on the periodic table, which means it keeps its charge. In order for the entire compound, KBr and KCl, to be neutral, that means that both the bromine and the chlorine need to have the same oxidation number of -1. Again, in order for the whole compound to be neutral. Okay, so the only thing that's changing is the chlorine and the bromine. If you look from one side of the other, chlorine is going down and bromine is going up because -1 to 0 is up. So chlorine is reduced and bromine is oxidized. Because it went up in oxidation number. That is our only thing we are concerned about at this time. If it's going up or if it's going down, that's it. Okay. So we're going to do this again. Find oxidation numbers for the next problem. Again, single elements are 0, no exception. Oxygen is usually -2. Now, oxygen is -2 everywhere, unless it is in peroxide, which it is not. Okay, hydrogen also has a is usually, and that is +1. So anytime you see a hydrogen, it is pretty safe to say that it is +1. Okay, so water is taken care of. It is neutral. I've got 2 +1s and 1 -2, which is neutral. NO2, that one is not complete. We need to make N +4 in order for it to become neutral. And in NO3, HNO3, it must be +5. Any NO3 will have an N value of +5, and you can do the X to find that out. Copper, because nitrogen has a -1 charge, or nitrate, not nitrogen, you can safely assume that this copper has a +2 charge because there are 2 total -1 nitrates in this problem. Now I need you to figure out which element was oxidized and which was reduced. There will be 1 element of each. That's it, just 1. That's really all there is to today's lesson. I hope you're okay with oxidation and reduction. If not, I will have tutoring tomorrow, Wednesday morning. There will not be tutoring on Wednesday after school, but there will also be tutoring on Thursday morning. And I will leave a note. The POGL is classwork. The single sheet is homework.